Today we are going to look at lesson 2-2, and that would be on page 85 in your book. We are going to look at percents greater than 100 and less than 1%. I can understand that percents can be greater than 100 or less than 1%, and use a 10 by 10 grid and bar diagrams to represent them. Learn percents greater than 100. So the tables here show the total rainfall during April for a city in 3 different years. So if I look at this table, I have April rainfall, year 2017, 2018, 2019. And it says IN, that is the abbreviation for inches. So in 2017, April rainfall was 4 inches. 2018 rainfall was 3 inches. 2019 in April rainfall was 5 inches. In 2018, it rained less than it did in 2017. So 2018 is less than 2017. So 3 is less than 4. To compare the rainfall in 2018 to that of 2017, we can use this ratio of 3 to 4. Recall that a percent is a ratio that compares the number to 100. That is something to remember, please. You can use equivalent ratios to show that the rainfall in 2018 was 75% of the rainfall in 2017. And how we would do that is we would find an equivalent ratio. We have a part to a whole, so 3 to 4, and then we would make it so that the number is being compared to 100, because remember up above it compares to 100. We can get the 4 by multiplying it by 25 to 100, and then we do the same thing to the 3. We times it by 25 to get 75. So if we have this 75 over 100, we know that it would represent 75%. In 2019, it rained more than it did in 2017. To compare the rainfall in 2019 to that of 2017, use a 5 to 4 ratio. You can use equivalent ratios to show this rainfall in 2019 as 125% of 2017. It is greater than 100%. So again, we have the ratio of 5 to 4 as a part to a whole. And we can take the 4 and get it to 100 because we're always comparing it to 100% by multiplying it by 25. And then we need to do the same to the top, to the 5. 5 times 25 is 125%. So percents are greater than 100 when the number being compared to 100 is greater than 100. When the percent is greater than 100, the part is greater than the whole. This is something important to know. Please underline it. So 25% means 25 per 100. So our model is going to look a little different than it did for lesson 2-1. We have 100%. So we have the 10 by 10 grid. We have 100 squares filled in. And then we need to add 10, 20, 25. So we would use both of these 10 by 10 grids to show the 125%. Suppose the rainfall in 2020 is 5 inches. What percent compares the rainfall in 2020 to the rainfall in 2019? So let's look up here. Let's go back to the table at the top. We're comparing 2020, so I'm going to add to this, put 2020. And it said in our question, the talk about it question here, that 2020 had 5%. So I'm going to underline what we're looking for, what percent compares. And at this point, 5% is what we need to look at, 5 inches. So I'm going to go back up here to the 2020 and add 5 inches. So if I take a look here at 2019 and 2020, they both are 5 inches. So we need this information when we come down here. Suppose the rainfall in 2020 is 5 inches. What percent compares the rainfall in 2020 to that in 2019? So what we would do is we would say, okay, it's 5 to 5 or 5 to 5. And at this point, we would say it is 100% because they are the same items. They are the same number. They are equal. So they are equal for 2019 and 2020. They are equal. So it would be 100%, which that would equal 100%. We are finished with page 85. Continue on with page 86. If we're going on to page 86, at the very top, it says example, identify the percent. What percent is represented by this 10 by 10 grid? So at the bottom of page 85, we saw that this bottom of page 85, one complete 10 by 10 grid is 100%. So we can use that to help us with these questions. So what percent is represented by this set of grids? So this would be 100%, 100%. Then we would need to count 10, 20, 30, 40, 50, 60, 61, 62, 63%. And so if we're taking a look at this, we would say the percent compares to the number of shaded squares to 100. So we're comparing it to 100. Percents are always compared to 100. How many whole grids are there? There's one whole grid here, one whole grid here, so there's two whole grids. How many squares are shaded in the thirds? And that would be 63. How many shaded altogether? Altogether, we would have 100, 200, and 63. So 263 squares are shaded in. Write the ratio that compares the total number of shaded squares to one whole grid of 100 squares. So the ratio is 263 to 100, or 263 to 100, or 263 over 100. So the percent represented by the 10 by 10 grids would be 263%. So how many squares are in each of these grids? And at this point, we can say 100 because they're 10 by 10. So there's 10 by 10, 100, 100, 100, but 263 are shaded. How can you quickly determine the number of shaded squares without counting every square? So you saw that in the last video I was doing this, and I continue to do it. I know that each of these columns or rows are 10, so I can count 10, 20, 30, 40, 50, 60. I can count 60 real quick because I know these are all shaded in, all these squares are shaded in, and so I can just count by tens. So I could say I could count by tens, for shaded rows or columns. Let's go on to the bottom part. Check. What percent is represented by this 10 by 10, these 10 by 10 grids? So we know here this is 100, and then we have 10, 20, 30, 31, 32, 33, 34, 35, 36, 37. So the percent that I am looking for would be 137%. I would add those together and create a percent. This is the end of page 86. Going on to page 87. At the top, example 2, model a percent. At birth, the average kitten weighs 5 ounces. At 3 weeks of age, the average kitten will weigh twice as much as at birth. Write a percent that compares a kitten's weight at 3 weeks to its weight at birth. Use a 10 by 10 grid to model this. So at 3 weeks of age, the kitten will weigh how many ounces? And it says right here, 10 ounces is twice as much as 5. So I would write down 10 because we start out at birth at 5 ounces. And then 3 weeks, it says it's twice as much. So 2 times 5 is 10, twice as much. Write a ratio comparing the average kitten's weight at 3 weeks to the age to its weight at birth. Use equivalent ratios to show the average kitten's weight at 3 weeks of age is blank percent its weight at birth. So let's talk about this. Here its weight at birth is 5. Its weight at 3 weeks would be 10. So we're changing this into a percent. And we know that with the 5, we can multiply it by 20 to get 100. Because remember, a percent is comparing to 100. So we always want to compare to 100. So to create an equivalent ratio, we need to take 10, multiply it by 20. If we multiply it by 20, we would have 200 over 100. So draw and shade a 10 by 10 grids to model 200%. So 200% is the same as 200 over 100. So I would take my grid. Here's a 10 by 10 grid. Here's a second 10 by 10 grid. And to show and model of 200%, we would shade in the entire thing. Because we have 100 plus 100 equals 200. Think about it. If the kitten's weight did not change, what percent would compare its unchanged weight to its birth weight? So we need to think about this. If it's unchanged, we would have 5 over 5, 5 over 5, because it said it started out at 5 ounces. So 5 out of 5 would be 100%. Check. At the bottom of page 87. At birth, a male baby giraffe stands almost 6 feet tall. At 4 years of age, the male giraffe will be about 3 times as much as at birth. Write a percent that compares the giraffe's height at 4 years to its height at birth. Then draw a grid. So if I am saying we are starting out at 6 feet and then 3 times as much, so if it's 3 times as much, if we go back and if we look at this example 2, it said twice as much. And if we did twice as much, we found that it was 200%. If I'm looking here and it says 3 times as much, we would be looking at 300% increase. So 6 times 3 starts at birth at 6 feet. It's 3 times as much. And so it would be 300%. It would be 18 feet tall. 18 feet tall. 300%. And then we would draw 3 10 by 10s. So it's 3 times as much. This is 10 by 10. 100 squares. 10 by 10. 100 squares. 10 by 10. 100 squares. So if I'm taking a look at this to think about this, it weighs this much at birth. If I'm just looking at the model, the visual cues to help me, it weighs this much at birth, And then at 4 years, it's 3 times as much. So it would weigh all three of these, which would be the 100% plus 100% plus 100%, which would be the 300%. That is all for page 87. Going on to page 88, the top of 88. Learn percents less than 1%.